Okay, so I've been through the very complicated topic of how all this comes into place. You will probably need to watch that 2 or 3 times to kind of understand what's going on. It's very tricky, okay? So don't worry if you're not completely sure you get it yet. But for now, I'm going to run through some examples of this in action. So say we get a question like this. If y equals 4x squared, prove from first principles that dy by dx equals 8x. Now we know it does, don't we? Because if we multiply by the power, we times it by 2, yeah, sorry, it should be a 4. And we decrease the power by 1, so you get x. So we know it's going to be 8x, right? By using the rules we learned in the first lesson on how to differentiate, but we have to do it from first principles now. So what we're going to do is recall that horrible formula from the previous page, okay? F of x plus h minus f of x over h. Now, how do we actually use this? Okay, the first thing to notice is what is our f of x? Our f of x is whatever equation we're given, so it's 4x squared in this case. That is our f of x. Okay, so that f of x is going to go into here in the formula. But the question is, how do we get this bit, this f of x plus h? Okay, what we do is, when we see an x in the formula, we replace it with x plus h. Okay, so f of x plus h, you put x plus h in instead of just an x. Okay, so I've got 4x squared, but because I'm doing x plus h, I do 4 of x plus h squared. Okay, and the square goes on the outside of the bracket. Okay, so all I've done is replace this x with x plus h instead. Okay, that's how we get f of x plus h. It's a tricky step, so make sure you're happy with that idea. All we're doing is replacing x with x plus h. Right, x plus h squared, I'll come up here a second. You should find, you should be okay with doing this. Write it as double brackets like this, and then multiply them out. You get x squared plus h squared plus 2xh. That's what I've got here. I've still got that 4, so I can multiply that 4 out, and I've got this. Now I've got that, I can start to fill in the formula. F of x plus h was this. Okay, so I've filled that in the formula here. F of x was just 4x squared, so I've filled that in over here, minus f of x, like it says in the formula, and h on the bottom. Basically, all I need to do now is simplify everything, and I'll find the answer. Okay, can you see I've got a 4x squared here and a minus 4x squared here? They're going to cancel each other out. Okay, they disappear, and I'm just left with 4h squared plus 8xh on the top. Even better, I can now cancel the h. So this h can go, so that h will go, and that squared will go. I'm just cancelling an h from the top and an h from the bottom. And I'm just left with 4h plus 8x. Now remember, the formula says the limit as h approaches 0. Now if h approaches 0, this whole term is going to become 4 times 0, which is just 0. Which means I'm just left with 8x. Okay? And there's my dy by dx is 8x, which matches what we know the answer is by doing the differentiation. Okay, so you can see by using this horrendous formula from very first principles of just thinking about the gradient, we can show that dy by dx is 8x. Now you might think, why do we bother? Why do we not just use the standard formula? That formula that I showed you in the first lesson, that only works when we have something of the form x to the power n. Okay, it doesn't work for anything else. This formula here works for absolutely anything. You could differentiate sine x with this. You could differentiate the exponential function with this. You could differentiate absolutely anything with this. Okay, whereas the formula I showed you only works if we have, x to the 4 or 3x to the 3, that sort of thing. Okay, so that's why it's quite important to understand how this works. Let's have a look at another example. This is slightly tricky, I'm afraid, but this is about the hardest thing they could ask you in the exam to do from first principles. Right, again, if we had 2x cubed, have a think about what the derivative is. We multiply by the power, so we get 3 times 2x cubed, and reduce the power by 1, becomes squared, so we can see it's going to become 6x squared. But how do we get that from first principles? Well, we use that horrible formula again. F of x, remember, is just the equation they give you. It's just the 2x cubed in this case, because y equals f of x. Okay? F of x plus h is slightly trickier. Just remember, wherever the x is, we replace it with x plus h. Okay, so instead of x cubed, we get x plus h cubed. So f of x plus h is 2 lots of x plus h cubed, because we're replacing that x with x plus h. Okay, this is going to be nasty. Okay, x plus h cubed, you have to work out like this: x plus h, x plus h, x plus h. Okay, now this will take a while, but it's not actually all that tricky. You just need to concentrate. If you multiply out the first two brackets, you'll get x squared plus h squared plus 2xh. But we still need to multiply it by the third bracket. If you do that, I'm going to multiply them all by this term first. You get x cubed plus xh squared plus 2x squared h. Now I'm going to multiply it all by the h. I get x squared h plus h cubed plus 2xh squared. Okay, that's pretty nasty, isn't it? You should be relatively confident multiplying out triple brackets. Make sure you're okay with it. Just do two of the brackets first and then multiply it by the third one, okay? We can do a bit of simplifying here. We get x cubed. There's an h cubed there. Now, xh squared, there should be another term. Here's an xh squared as well. These can be combined together. We've got 1xh squared plus 2xh squared gives you 3xh squared. And again, this term and this term, 2x squared h plus x squared h gives you 3x squared h. Okay? And that's what I've put in here. Okay, so it's really painful multiplying that out. But you just have to take your time with it. And it's two lots of it, so it all has to be multiplied by 2, which is what I've done here. And that is f of x plus h. We can throw all that into our formula now. Okay, so all I've done is put all of this in minus f of x, because that's what the formula tells us to do. F of x plus h minus f of x, all over h. At this point, we just really need to tidy up. First thing you can see is this first term, 2x cubed, cancels with this last term, minus 2x cubed. That will always happen when you do your questions from first principles, okay? Those two terms will always cancel out. So you're left with 2h cubed plus 6x squared h plus 6xh squared over h. We now want to do cancelling with the h again, just like we did in the previous example. So we're going to cancel this h. So that cubed is going to become a squared because we cancel an h. That h disappears. And this squared disappears, just leaving h. Okay, so you get 2h squared plus 6x squared plus 6xh. Now remember, we got a limit. H is approaching 0. So if we look at this term, I'm going to get 2 lots of 0 squared, which is 0. There's not an h in this term, so it doesn't change. This one's going to become 6xx times 0, which is 0. So all I'm left with is that 6x squared. Okay, and that, from looking right back to the start, matches with what we get from the differentiation formula. And this is how you do it from first principles. This is the hardest thing they could really ask you, because doing it with an x cubed is as hard as they're allowed to ask you to do it. They won't ask you to do it with an x to the 4 or an x to the 5. It just takes too long. X cubed is the highest power that they'll ask you in the exam. So make sure, if you can do this type of example, you really will be okay with this proof from first principles stuff. Okay. Yeah, it shouldn't really get any harder than this. I know it looks, if you look at this page, it looks really nasty, doesn't it? But if you follow each step, it's not too bad. You just need to be really confident multiplying out brackets and simplifying.